Hello, good morning everyone. Good afternoon, depending where you all are. Welcome to today's webinar from Enterprise IoT Insights. Our topic today is industrial IoT security and the practicalities of securing manufacturing and supply chain IoT systems. My name is James Blackman. I'll be chairing today's event. Alongside me, I'd like to welcome a fantastic panel of experts, which will each present on the subject before we open up to a Q&A session. Our panelists are, in order of appearance today, Brian Arbuckle, Senior Market Analyst at IHS Markit, Stefan Quetglas, Director of Enterprise IoT Marketing at Gemalto, and Jay Thoden van Veltzen, Director of IoT Security at SAP. Welcome all. Thank you very much for joining us. Just some background to start to let you know something about Enterprise IoT Insights, which is bringing you this webinar today, as well as a long editorial report published in tandem with it. So Enterprise IoT Insights is a premier news source for enterprise decision makers, launched by RCR Wireless News in 2016. The target audience is executives and volume buyers at enterprise class organizations. You can find us online and on Twitter. The various go-to addresses are there. The report is available online too, I believe. Just add the /channels/reports to the homepage URL, as you can see at the bottom of your screen there. Some context just to begin with. I'm going to skip through some of the findings of the report. You'll all have seen the variations of this slide. The message, as we know, is the Internet of Things will usher in a fourth industrial revolution, that the factories of the world will be networked, their machines will be connected, their processes will be slicker, their innovation will be faster. That's the vision, and the growth forecasts, as you can see on your screen, are gigantic. Gartner says there'll be 20 billion things by 2020, but the attack surface is getting bigger all the while. The opportunity for hackers is greater all the time, and the industry at large is way behind. This slide shows the top 10 security vulnerabilities as published by the Open Web Application Security Program. And what we can see is the same failures keep cropping up from the IT world. Really, these are schoolboy errors, default passwords, weak passwords, no account lockouts, no two-way authentication, exposed ports, no transport encryption. The industry at large, we understand, is losing the battle. And we have here some reports, some quotes from the report itself. So this is KPN in the Netherlands. We keep making the same mistakes. We just haven't learned. It's like the goldfish with the 1 second memory. We get surprised at lessons we already know. Why is that? Why is the market failing to secure its systems and to inspire trust? Because the ecosystem is complex, and there is no easy way to create order amid this chaos. Again, in the report, Telefonica puts it well: complexity is the enemy of security. There are a huge variety of devices, networks, and cloud platforms. That heterogeneity is a challenge. It's not always helpful to play the blame game with this stuff. Actually, in this market, it is hard not to. Devices are the weakest link. The real risk, as Webbridge says, the real risk is the ignorance of the product makers which build these things without any security in mind. ultimately, there are no silver bullets. This is a moving target. There are any number of cliches you can apply here. As it stands, most IoT solutions require bespoke layers of security. The more you pile on, the safer you are. IoT systems must be secured end-to-end, as ARM says, and adapt to the threat landscape. Security cannot be solved at a single point. It must be pervasive. But this is all fairly general. In terms of an industrial diagnosis, there are unique symptoms. The first point, very obvious, is the stakes are higher, and not just this idea of critical infrastructure and keeping the lights on, which is the gamble, but also the bright ideas that spur innovation. As Verizon says in the report, the biggest issue in manufacturing is cyber espionage, and it reckons 90% of security incidents in manufacturing are linked with the theft of corporate secrets. The industry is in a catch-22 between the desire to harness IoT and the fear of its insecurities. They know they can improve productivity, but they don't want to compromise safety. They understand the risks, but they don't know how to manage them. The big question in this space is how to connect OT and IT, of course, so the magic can happen. And these systems have historically been kept at arm's length. In IoT, we are deliberately bridging the OT-IT divide, potentially or inevitably altering the nature of isolation. And the problem is, as well, these newly connected systems are running old technology, dating back to the early 90s in some cases, to Windows 3.1 to Windows NT. It is dangerous, potentially, to join them up. What they're really doing is bolting new technology onto a lot of older systems, says AT&T, without reviewing the security aspects. But the diagnosis is easy. The treatment is less so. The report makes recommendations. The rest of this session will do the same. But briefly, some thoughts just to end with. IoT is a journey. It's better taken one step at a time. You don't have to chuck it all out and start again. There are ways to secure this legacy equipment now. And the steps are pretty well understood. Step 1, audit, review, take stock, review your position, manage what you can out of the door. The first step with this legacy stuff is not to introduce more of it. Step 2, get the basics right, identity and authentication, firmware upgrades, device management, all that good stuff. Step 3, design security in from the start by sticking to your first principles. And just finally, a quick, a word on those principles. Simplify your design, isolate your critical systems, encrypt your transmissions, authenticate access, automate security processes, and that way you can build trust, which builds security. And that's it from me. Like I say, the report is online, so you can see more of this. I would like now to get the show on the road properly and to hand over to our panelists in turn, starting with Brian Arbuckle from IHS Markit, who can build on this introduction with some deeper insight. Brian, thanks for joining us. It's all yours.
Thank you, James. Hello, everyone. I'm Brian Arbuckle. Last year, I published a report on cybersecurity for industrial control systems, looking at the market for security hardware, software, and services up to 2020. Now, one of the key drivers in this market is the growth of what's being called the Industrial Internet of Things, or IoT, because of the additional efforts that will be required to secure industrial networks with many new IP-connected devices. So I think it's important to be clear about the different priorities of operational technology, OT, and information technology in industrial cybersecurity. So OT is about ensuring production asset availability, efficiency, and safety. For example, preventing denial of service attacks in critical infrastructure. Traditionally, industry standard network protocols rather than IP are used. With IT, it's about prioritizing data confidentiality and brand reputation. For example, trying to prevent corporate and personal data loss, exclusively IP network protocols. Now, finding the expertise to manage both IT and OT cybersecurity can be a challenge in itself, which many companies find. So the evolution of industrial cybersecurity, in the early days, I think as James mentioned, operational control systems were connected through serial communications, not networked. And even when networking was adopted, a complete air gap usually existed between the IT and OT networks. And OT networks use proprietary protocols unfamiliar to attackers. As the Internet of Things grows and evolves, we're expecting significant growth of IP-connected devices used in control systems, manufacturing, utilities, and transportation. So understandably, doubts are being raised over whether these new points of access will simply increase vulnerabilities. For example, hacking into an unsecured sensor could lead to uncontrolled change in a hazardous condition or shutdown. On top of the new threat of new connected sensors, we still need to fix all the vulnerabilities of what already exists. Understanding the security considerations of the legacy protocols and systems and building secure architectures to allow new sensors to be attached is a must for industry. So what needs to be secured? We have millions of legacy industrial devices which need to be secured, some decades old, some new, and virtually all vulnerabilities. When security patches are required, implementing these can be a severe challenge for end users due to a variety of logistical issues. Compounding the weaknesses in legacy systems, we're expecting to see both an increase in IP connections and a greater number of IP-connected sensors, growing the universe of devices needing to be secured. So why are we doing this? To achieve levels of control and increase productivity not previously possible, in order to achieve prosperity and drive economic growth. So thinking about the additional challenge of these new IoT devices in a positive way, could they drive a new virtuous circle of cybersecurity technology development? Next slide, James. So security technology solutions have to be engineered to defeat human ingenuity. And as a result, there's a cyclical pattern of threat protection technology development. New threats emerge, new technologies are built to combat those threats, and those technologies are absorbed into larger platforms and the process repeats itself. So in detail, looking at evolving threats, security technology innovation driven by changes in the threat landscape, and that landscape is ever changing. Device proliferation, whether it's IoT sensors, smartphones, tablets, machine-to-machine communications, it means more traffic on the network and more need for network visibility. Rationalizing defense. Defense tools and strategies have been built over time, layering new technology on top of old as new threats emerge, leaving most companies with a complicated infrastructure with many holes. Efforts are being made to simplify security architecture and protection to make it more effective. So new architectures, implementing a good network architecture by securing the ICS environment and the standards, technology, and expertise all exist to do that successfully. And guidance is available in the NIST guidance, Guide to Industrial System Security, and in the ISO/IEC 62443, Security for Industrial Automation and Control Systems. Next slide. So, given the perceived vulnerabilities in IP-connected devices, will security not be embedded in new IoT sensors? Well, not to any great extent, according to a recent IHS Markit study, which suggests that only 2 to 3% will have hardware-based security code processors seen as the gold standard for embedded security. Security code processors are currently viewed as impractical in every device. Why? Cost and complexity are the main issues. Is there an alternative approach? A number of organizations are looking at alternative systems to achieve trustworthiness for IoT systems. The Industrial Internet Consortium aims to create a broad industry consensus on how to secure IoT systems and are active in promoting the acceleration of secure IoT adoption. Slide. So do users have concerns with deploying IoT solutions to achieve the promised productivity goals? Well, IHS Markit recently investigated the question of what users perceived were the greatest impediments to deploying IoT solutions. The number one issue was indeed security, closely followed by cost and complexity. The lack of standards and interoperability was also mentioned, and the lack of a clear return on investment tended to undermine the business case. So unless perceptions change, the uptake of new IoT sensors and industrial networks may be somewhat constrained by user concerns. A delay may not be so unwelcome, as there's much work to be done to secure existing assets. So in summary, long life cycles in manufacturing industries lead to slow evolution in control technology, and with it a mix of new and legacy systems. Understanding the security considerations of legacy protocols and systems will continue to be important. And addressing security concerns and building more secure industrial environments will help drive and accelerate the growth of the industrial Internet of Things. Thank you.
Thank you, Brian. That was great, really informative. I'd like to, we're a little bit behind schedule, so we're going to move right on. I'd like now to introduce Stefan Quetglas, Director of Enterprise Marketing at Gemalto. Stefan, thanks for being here. Over to you.
Thank you, James. Hello, everyone. So I'm going to talk a little bit about what's going on into factories as far as smart manufacturing is concerned, and focus also on asset management, which is a very interesting area of improvement in factories. Next slide, please. Yeah, so a few words about Gemalto, because maybe not everyone knows Gemalto in this field. Gemalto is a digital security specialist. So what we're doing is that we enable trusted digital communication at large. It's all about securing exchanges between people or things, with businesses and governments when digital assets are involved. So what we provide is secure software at the core of the network and the cloud, but also at the edge, to achieve two basic things like authenticating people and things and protecting data. So we do this for 5 markets, and Internet of Things is one of them. We are trusted by some of the world's biggest brands, and you can see a few names here. But okay, let's move on to the topic of the day. What we see today in terms of evolution in factories is that we're moving from an organization that's quite hierarchical in I would say silos, to an organization that is much more complicated, that is much more resembling to a value network than a value chain, with a lot of different interactions. And what is it? So it is because the goal here is to enhance further productivity and give more flexibility to the factories. And these factories, it's important also to know that there are more and more manufacturing and producing devices that become smart, meaning these devices themselves become connected. So multiple points of interaction exist within the factory, connecting the different assets, machines, tools, also people, of course. And now product is in this network because products are connected on the field and they can feed back information to the factory itself. And that is not the only change. This is the other change is that factories are interacting in a more and more dynamic way with external parties through that can be suppliers, that can be players in the supply chain, or also with the cloud service providers, because they provide interesting services to further improve the factory operations. So all in all, what does it mean? It means that there's a big change in terms of attack surface and potential issues. And when I would say potential, it's not actually just an hypothetical risk. If we look at the past, already we've seen a lot of different attacks on industrial systems and for instance, nuclear plants. Like the famous Stuxnet, it was 7 years ago. It's a very, very famous one, followed by others like Dragonfly, also known as Havex, targeting more the pharmaceutical industry to specifically steal IP in this case, or cases in Germany with a blast furnace that was had to be shut down because it nearly basically it has now been destroyed by remote attacks. The other example in Ukraine on the power grid is in the same class, I would say, with the hackers taking control of the industrial control systems, the PLCs, for instance, and coming through, in most cases, through the IT side of the network. And last but not the least is Petya ransomware, very, very much quite recent one, where cyber attacks actually impacted a lot of companies, but a famous one is Maersk, the shipping giant, and we had a figure for the business impact of nearly $300 million in this case. And in many of these cases, the problem is that the business continuity was impacted, also safety, and most of the time these attacks they came from the IT systems. And now that we are connecting more and more the IT systems with the OT systems in factories to achieve these benefits I was mentioning before, and these problems just rise actually. So trust is needed to ensure business continuity, which is very important, but what is even more important in factories, in the manufacturing sector, is to ensure safety as well. So now let's have a look at assets and how we manage them in factories. Why managing assets is an important topic here. It's because it enables two very important use cases that can bring clear benefits in the short term to manufacturers. The first one is about enabling predictive maintenance with the analysis of data coming from the assets, the status of the assets, and the way the status is evolving. Here you can apply smart algorithms to improve the way you maintain these assets. The second one is the digital performance management that also relies on this flow of data coming from assets that you are able to identify, locate, check status, etc. It's a little bit different from predictive maintenance in the way that it's more about looking at the overall factory. But then managing assets in this ecosystem that is more like a value network, like I said before, presents some challenges. And what we think is important there is to make sure that basic principles like authenticating assets, managing data, protecting data, and managing the life cycle of these assets is very important. So you can do it in different ways depending on how these assets are connected, actually. They can be connected through direct means, For instance, say a robot could be connected directly to the asset management system. They can be connected to through gateways as well, that are all either connected to a fixed network, or they can use wireless technologies, LP1 technologies, and even cellular technologies, depending on the settings. So adding to these assets the right means to perform these three important activities: authentication, lifecycle, and data protection, can be done in two different ways. Can be implemented directly in the asset or in the gateways themselves. And what is also important to do is to consider the other side of this assets management activity, which is, what are my assets that are actually connected to cloud applications? I may be using a cloud application, a cloud service for predictive maintenance, for instance. So all in all, you need trusted masters in your factory to make sure that they know perfectly what are the devices that are connected, that they are genuine, that they send data you can trust, and that this data, when it is shared with a trusted partner, then it is still protected. So the interesting technology to do that is clearly PKI, with certificates, credentials deployed in devices. Uniquely assigned identities for devices, and specifically in this context of manufacturing, OPC UA is a very good technology featuring already these concepts based on PKI that help you securing asset management. So just to conclude, in terms of steps, we see 5 interesting steps to perform for enhancing the factory, enhancing specifically asset management within the factories. First, to perform the risk analysis to define the right assets and the protection levels that you need, because it can depend whether you're talking about a single sensor, a robot, or a group of actuators, for instance. The protection can be implemented either directly in the assets or through the gateways, and gateways, they are a great way to improve the existing solutions, because they can provide an additional layer of security for data, for instance, without forcing you to upgrade these sensors they are aggregating. Protecting data, address, and emotion is important as well, and using separate networks that are wireless can minimize the impact on legacy. And last point, that very, very important, security is not a static thing. So having a lifecycle management solution in place is very, very, very important as well. Thank you.
Okay, thanks, Stefan. That was great. There was a lot in there, a lot to think about. We're gonna move on again quickly. I'd like to introduce Jay Thoden van Veltzen from SAP, who has a concrete use case about how all this stuff can work. Jay, it's great to have you with us. Take it away.
Thank you very much, James, and thanks the other panelists, and also thanks Stefan for, in fact, providing already a little bit of an introduction into my slide. So I'll take the next one. So this is a bit of a maybe silly representation, but one of the things that I came across in the last sort of 2.5 years that I've been looking into IoT security is that sometimes our conceptual frameworks can trap us to the point where, you know, it becomes hard for us to figure out what to do. So we all know this quote. We actually saw this on James's introductory slides as well, of 20 or 30 or 50 billion connected devices by 2020, connected to everything, and that's essentially what the little diagram here on the left is trying to say. But if you actually think about that, that's already not really the case. Even in sort of a home automation type situations, what you typically see is that you have a particular device that you bring in your home, you put that on your wireless network, you configure that with a smartphone app, and now your smartphone app is essentially the bridge between the cloud and that particular product. But if you have 5 or 6 of them, essentially none of these networks really cross over into each other. The only thing that is sort of the same is the hub of your smartphone. So already we're really talking more about networks of networks. And I think when it comes to actual IoT solutions, especially in industrial, what we're likely to see is that we have these multiple networks that are essentially separate from each other and aggregate data up into the cloud. And I will give a representation of that in a short moment. Next slide. So as Stefan also said, encryption is absolutely critical in here, and we welcome very much the move towards OPC-UA, which, and I know that OPC-UA experts will beat me up over this, but for those who are not entirely aware, OPC-UA, I would call it like TLS for industrial protocols. That's probably the easiest way to think of it. It will provide both encryption of the data as well as signing on both ends. So, client certificate, server certificate, each can prove that the other is indeed the one that they say they are. And another important point that you see a lot in IoT is this use of a gateway model, where the transmission of the IoT device to the gateway is over a relatively weak protocol, and it's then secure from the gateway. That's nice, but it's very partial, right? The security from the gateway to, say, a cloud endpoint, to break into that would require some significant effort of, poisoning DNS caches and so on. Whereas, proximity to the IoT device and the IoT gateway, when it runs over wireless, is typically where things get a little problematic. So we take a very strong position that encryption should take place on the device and only get resolved on the location where this data gets ingested. I'll take the next slide. Now, there's one problem with this, and that is that beyond 32-bit and above chip architectures, we're getting into real critical or problematic areas when it comes for encryption for low-power devices. So we actually developed an encryption scheme specifically designed for LPWAN to keep that data secure and encrypt the data on the device, and only resolve it once we get to the cloud environment. There's some description in here, but in the interest of time, I will actually skip that. So go to the next slide, please. And here's where all of this actually fits together. What you're looking at here is a diagram of the data flows between a largely SAP manufacturing solution. And this is fairly typical to what, at least parts of this are fairly typical to what most manufacturing organizations already have in place. If you hit it one more, then we'll have a little bit of a functional explanation of the various parts. So at the very bottom, you have the OT layer of machines and sensors. This also includes potentially historian and manufacturing execution systems and so on, as well as additional sensors. So obviously, many of these machines already have sensors baked into them themselves, but in many cases, there's valid reasons to have an additional sensor network for additional environmental and other types of data. Then in the big block marked IT/OT gateway is essentially our combination of planned connectivity and dynamic edge processing. And its function is ideally over OPC-UA, connect into that OT layer and either query, subscribe, or push data back into that environment. While on the left side, you see the manufacturing suite, and there's various data flows from the connectivity layer into that environment. That is connected to ERP, which is the enterprise resource planning system that essentially every large organization runs on. And then we did an interesting thing, is we push data from ERP and the manufacturing suite through something that we call the cloud connector, which is essentially sort of a VPN proxy into the cloud environment. So for the IT environment, going through that layer, the cloud will actually appear to be local. And then finally, on the top, you see cloud applications. Those are largely for things like analytics. If you have multiple plants, we can send data from multiple plants into that so you can see it in one dashboard. But this also includes things like predictive maintenance, big data analysis, and predictive quality management. Next slide, please. So if you look at this from a sort of network separation perspective, what we have is an OT network that is essentially the networks that run the Siemens, ABB, Rockwell, etc. machines, the PLCs and the DCSs, ideally communicating over OPC UA. We can do it as well with legacy protocols, but if OPC UA is available, then we will absolutely use that. If the customer hasn't implemented that or hasn't implemented that fully, we'll certainly ask them to put that on the roadmap. So this connectivity layer, you may want to hit it one more time. Yeah, the connectivity layer, so the big blue box there, is essentially a gateway. So it has an interface card pointing into the OT network and one into the IT network, sharing data with the manufacturing suite. And it's very important to recognize that this is a landscape that is not exactly new. The new parts really here are the cloud environments and any supplemental sensor networks. Yes, there's now more functionality than there was in the past, where this system was largely used for reporting purposes. And there's now a capability to push data back down into the OT layer, in essence, enabling things like order-driven manufacturing. So, we clearly understand that there are additional risks involved. But rather than build something entirely new, we actually build on top of things that, first of all, customers already are familiar with and likely already have in place in one shape or another, and then find a secure and controlled way to get data from the IT environment into the cloud. So you don't actually see any direct connection here from the OT network into the cloud at all. That goes through the IT layer, through applications that all have ACLs and user accounts and segregation of duty and all of that stuff, through a cloud connector that only designated hosts can even communicate with, into the cloud. And then if you hit it one more time. And then what you see on the right here is a sensor network on LPWAN. And it's very important to realize that the sensors at the very bottom actually share the same physical location of the machine's environment itself, but they are on a completely and totally different network. Obviously, we think it's important that we would deploy onto those sensors our data encryption scheme, so that that entire traffic from sensor through the gateway, through the LP1 provider, into our cloud environment is fully secured and there can be combined with the data that comes out of the IT environment for further analysis. And I'll take the next slide. So I think a really important part of this is that when, just like the conceptual framework of everything connecting to everything very quickly makes you throw up your hands and like, how are we going to protect that? What you see in this, and what we also see with in the reaction from our customers, is that where they thought IoT was this massive sort of step function that you had to do massive amounts of prep work for before you could do this in any kind of controlled way, is that actually a lot of this is continuity, right? A lot of these our customers in manufacturing are already running plant connectivity, are already running MII, and are already running an ERP system. Now, there may be some additional functionality, but a lot of this is familiar. What also is familiar is the way to secure these things, because people have been setting up plant connectivity to MII and configuring MII to talk to ERP. All of that is encrypted, all of that is authenticated, where possible, digital certificates on the client side are used as well. We also recognize that manufacturing is very long tail, that equipment lasts for decades, and that very often that change is going to be very slow. So, that's why we also recognize that not everybody will have OPC UA fully implemented yet, perhaps. Let's get that on a roadmap, but we can get going because, frankly, if they haven't got OPC UA set up already, they have already been running their IT-OT bridge through plant connectivity before. So what is new is the cloud analytics, the sort of big data analysis of additional sensor feeds combined with business context. So that, for instance, you can figure out that, say, vibration on a machine could lead to problems with the quality of whatever is being produced, and figure out some way of scheduling a scheduled downtime to fix that. And the real value proposition really is of course the order-driven or ERP-driven manufacturing, which leads to mass-produced, personalized production. So implement OPC UA. I think that's just critical for the OT environment. End-to-end encryption between components, X509 PKI, where the equipment is capable of it. Limit number and tightly control the interfaces between networks. So as you saw, here it's very strictly controlled which piece connects into another connectivity layer. Use of LPWAN sensor networks with the added data protection, completely isolated from the OT network, so that the only way that, even if that environment would be broken and an attacker starts sending false data into the cloud, it would have to be of a level that we will almost certainly notice. And of course, we always need to get the basics right. So where there are passwords, use strong passwords. Set up strict segregations of duties and access control, firewalls, network segmentation, monitor everything, monitor your IT, monitor your OT environment, and do any auditing and all of that stuff. But that's essentially all of the basics. And I hope that gives sort of an idea of what a real manufacturing environment might actually look like.
Jay, thanks very much. That's fantastic, really fascinating. Thank you. Thank you all. We are running quite a way over, so I'm sure there'll be some questions following that. We have a couple come in. I just urge you, everyone who's listening, to get involved and ask questions. This session is for you, so get involved and ask your questions. A couple of points of housekeeping, just quickly. A recording of this will be available after the event, including slides. And if you need copies of slides, then you can be in touch with me at the top there. And equally, if you want to be in touch with any of the speakers today, then you can drop them a line. Their email addresses are here, and they will be available after the event. Just very quickly, we have a question here about the role of government in industrial IoT, and I guess this goes to regulation, this kind of stuff. Brian, perhaps you could pick this one up for me.
Okay, so the question is, what role can governments play in this? Well, I think the answer is quite a lot. If you think of the US, for example, at a federal government level, you've got things like the Chemical Facility Anti-Terrorism Standards legislation, and that means that high-risk facilities must have appropriate security policies, practices, and you need the people to prevent and protect and recover from incidents. So those big sweeping rafts of legislation are obviously going to make anyone in the industry set up and pay attention. Then you have, at the state level, you have individual states introducing bills and resolutions related to cybersecurity, covering things like improving government security practices, commissioning task forces and studies, or funding cybersecurity programs or targeting crime, computer crimes. You've got all that good stuff that does take a bit of time, maybe years to roll out. But the end result, you hope, is to get into a situation a bit like health and safety, where it's the CEOs of these organizations who carry the can if things don't work out the way they should and appropriate defenses aren't put in place. So I think government have got a lot to do there, and it can make a lot of change. Legislation and the threat of legislation is definitely driving the cybersecurity industry.
Brian, just quickly, we've got a question here about NIST defining cybersecurity framework to address the enterprise IT security needs. Do you see this as applying to industrial IoT? Presumably it does.
Do I see what?
Do you see this applying to industrial IoT?
I didn't quite get that question, but I mean, I think you have to sort of differentiate between standards, guidelines, or guidance, and legislation.
Sure.
That's both the ISO IEC and the NIST are effectively guidance rather than legislation per se, in my understanding.
Jay, is there something you would wish to add on this issue of the government's role in industrial IoT?
Yeah, because I think that it varies a little bit by what part of the world that you're talking about, and what sort of things would be welcome and what probably would be a little premature. For instance, I know that the Chinese government is pushing very hard on manufacturing companies implementing OPC-UA. That's a very welcoming one. There is federal legislation in the United States out of the Senate that seems to be written by a bunch of InfoSec professionals, because it gives some very rational, high-level requirements that equipment should comply with to be used by the federal government. I think those sort of initiatives are very helpful. Anything that gets very detailed too quickly, let's sort of think of the EU warning for cookies on every website, even though nowadays we know pretty well how to secure cookies, would probably be too premature. So these high level, make sure it has strong passwords, make sure that it doesn't have a hidden admin port and so on, I think will go a long way.
Yes. And Jay, this question here, we've got a question as well, which picks up on this OPC-UA stuff. It's a technical question about whether it includes intrusion detection and prevention sensors. You want to take that?
It does not. It's essentially a protocol communication interoperability layer that allows encryption and signing. So that's why I think it's probably easiest to think of it as TLS for industrial protocols. Anything like intrusion detection and prevention, you would have to add in yourself. There are certainly for OT environments a number of companies that provide monitoring solutions. That's probably what you're looking for at that point.
Okay. And Stefan, I wonder if you might pick this one. There's a question here about specialized AI, artificial intelligence processor devices being deployed at the edge of the factory floor to handle real-time analysis, and how that may impact security. Is that something you could pick up?
Sure. I would say in terms of local processing, when you perform real-time analysis with such technologies, that's really to make decisions local. That means in terms of security, the security risk is lower, because the data will remain local as well. And the same applies when you aggregate data and transfer data to the application, for instance. The risk is decreased. But anyway, I think as soon as you introduce communication and processing locally, you need to be careful with implementing the best practices in terms of security.
Sure. Okay. Thank you, Stefan. We have another question. We'll keep rolling with these questions from the audience, and keep submitting them. We want you you to be involved and to answer these questions. It's just Jay, maybe you might take this one. It's about your recommendations for data governance of the OT data.
Yeah, and obviously I can mostly talk to like how that flows out of the OT environment into the IT environment, and that is that typically through that connectivity layer that I outlined, we subscribe to specific tags, right? Or we look for very specific items that we then associate with business context in the manufacturing suite itself. So there is, by definition, an amount of data governance already happening by saying, like, okay, I now need to configure and outline and who has access rights to this particular piece of data that I'm getting out of the OT environment and passing that on to a very particular endpoint at the other end. So I would say that is largely baked into the way, like, it's not, say, a blind connectivity layer that just allows any traffic through. The configuration of these this OT interface will always be done on the basis of I'm picking that piece of data, I'm picking that other piece of data, rather than, you know, just send me this massive feed out of the environment. In fact, in many cases, what we'll do, especially where the frequency of sensor data is way too high to be of use to a business context, is that we either take an average or we take a, you know, every hundredth value if it's at some, you know, 100 hertz type frequency. So there are certainly very easy and controlled ways to control how do you get data out, who gets to do that, and where does it go.
Sure. Okay. Thank you, Jay. Thanks all. So just, I mean, perhaps if we can go back to basics. We have another question here about, you know, where do you start and your top 5 tips. But I mean, for a manufacturing business which is looking at the IoT now and looking, you know, is hearing the good message around what it can do in terms of their efficiencies and their innovation down the line and this kind of stuff. But are concerned, importantly, about these security aspects. What would we say are the, you know, important first steps to take? Stefan, I wonder if you might have a crack at that one. If you were to recommend a half dozen steps, you know, what might they be?
So I think first what is important to is to be really pragmatic about the use cases you want to implement, because you are not going to turn your factory into a smart factory 100% in a short amount of time. So first of all, it's all about identifying the use cases that you want to focus on. Could be, for instance, implementing predictive maintenance on a production line, not all the lines that you have in a factory, just one. And then you can start applying the basics that we've discussed already to implement this use case. Usually you will start with a proof of concept, but you need to make sure that you will be able, once you've proven the value of the use case you're implementing, that you will be able to scale up. And that means you need to put the right efforts in securing the solution that you're deploying. So authentication, identification of devices, encryption, etc. All these things needs to be, if not present from the proof of concept, at least you know that you will be able to add that without reworking the complete solution. So I would say there's no one answer that fits everyone, and it's really about what you really want to achieve first for your business.
Yes, thank you. Jay, I was interested in the example you gave with the sensor network off to the side, and keeping that, in the same physical plane, but isolated from your OT layer. I just wonder, is that the only way to introduce sensors into the industrial system, or are there other ways of doing it? Is this just one of many?
It's certainly one of many, and let's realize that there are certainly sensors already baked into the machines that you could get through the OT network directly. I think what we're talking about here is supplemental sensors that you would then use in a big data context to get further insights in that you apply subsequently. So it's more for sort of batch big data processing, whereas a lot of the sort of more immediate data flows from OT into the manufacturing side are more real time, if you like. But I think there is a really strong argument to be made to reduce risk simply by not messing with an environment that you're already comfortable with. I mean, this model, we didn't actually come up with it ourselves. It was our own manufacturing customers that made those choices. Specifically a very large German chemical manufacturer, because they were happy with the safety and security of the environment that they already had. And, any type of risk modeling of adding more sensors into that environment immediately brought this concern of, well, how will that affect the security and safety of my current OT environment? So by sidestepping that altogether and using an entirely different network that doesn't in any way, shape, or form have an ability even to talk to any of parts of the OT network, simply, sort of removes that risk entirely from the equation. I like to, anytime you do things where you can remove whole classes of bugs or vulnerabilities of risks are always really nice ones. So yes, there are other ways of doing it. Certainly as well in cases where you need to do a lot more edge processing that needs to take place on site, because obviously when you're using these LPWAN networks, there is no real processing locally. It all goes up into the network. So then there may be valid business reasons to have a sensor network more closer there. And there are other ways of doing it. It doesn't have to be by necessity LPWAN. That's a very cheap way of doing it. It could be GSM, right, or another network. I would hesitate to use something that is not industrial. So, for instance, I'm pretty happy with wireless HART. I would not bring Zigbee into an industrial environment.
Mm-hmm. Okay, Jay. Just while you're on a flow kind of thing. Well, what about 5G? Does that change things? Does that solve some of this?
It does to a certain extent, because it will run on equipment that is fully capable of doing modern cryptography. At the same time, though, the power consumption will be substantially higher. What you see often with these LPWAN sensors is that they can have a life cycle on a battery of multiple years, and we all know how often we have to recharge our cell phones. So there's just a big difference in the power consumption. But if the equipment can be powered to make that happen, then yes, modern X509 cryptography is always preferable over a solution that we need to run on something 8-bit.
Yes. Okay, thank you. It's been fascinating, and I think one of the takeouts really is that this is all possible. There's no reason to run scared of this stuff, and I think that's really, really positive for everyone. I just wonder finally, if just to round off, with a kind of it's simplistic, but a kind of a yes/no type of answer. Is there any excuse for enterprises of whichever stripe to get this stuff wrong, to fail to secure their IoT systems, or indeed to take advantage of IoT opportunities now? I wonder if each of you could just give a quick final verdict on that. Jay, what do you think?
No, but I think this is largely because security is not yet fully absorbed into global risk and compliance processes at companies. And I don't mean sort of the security compliance risk, but corporate global risk and compliance.
Brian, would you add anything to that?
No, I don't think there is any excuse for not using all best efforts to secure one's own networks. Can there be, could it possible the answer could be yes? I don't think so.
No. And Stefan, I mean, you're clearly from your presentation, it's something that needs to happen by degrees. You know, the change needs to be happened by degrees. IoT needs to be embraced. You know, it can be embraced now, but there's no reason to swap everything out. It seems very positive. Do you feel we're at a turning point with this yet?
Yeah, I think I agree that the answer is no. Now you have various ways of securing and adapting the level of protection that you want to achieve. With the risk level, you identify the threat level and to make also your business model or your business case fly. So I think that's really possible today. So no excuse.
Okay, great. Look, I think we're out of time, everybody, and we'll wrap up there. Thank you very much, everybody, for being involved. I'd like to take this opportunity to thank the panel. Brian Arbuckle, Senior Market Analyst at IHS Market. Stefan Kwetglas, Director of IoT Enterprise Marketing at Gemalto. Jay Thoden van Veltzen, Director of IoT Security at SAP. Thank you all very much. It's been a fascinating discussion. A reminder to everybody that the editorial report should be available now, just by adding /channels/reports to the Enterprise IoT Insights homepage. I encourage you to seek that out. But for now, I'd like to thank all of you for being with us today. We hope you found it informative, and until next time, thank you.